Hey there, future Java architects. Welcome back to Smart Architectural Programming, your go-to spot for mastering Java one building block at a time. And this is the final video if you're following along on our Introduction to Java book, and this is the last topic or video on chapter 5 basically, and you finally are stepping out into the more core fundamental building blocks of Java in the coming videos. Again, let's push ahead and talk about what we're going to cover in this video. We're diving into two super useful Java control flow tools, the break and continue statements. This is going to be a very short, succinct video, and we're just going to focus on exactly what the utility of these two statements are. And let's take control of our loops because they help a lot in control flow movements in Java in general. So with that, let's first understand what is the break statement in Java. So when you're talking about a break statement, we need to understand that the break statement allows us to exit a loop or a switch statement before it naturally finishes. It's like telling Java, okay, I'm done here, let's move on. So what do I mean by that, right? So let's put it this way. Let me use my marker tool here and get a color that wouldn't get hidden by the background here. So as we loop through this loop, right, we have this loop here. As we're going through this loop is going to keep on moving until it reaches the condition of when this value here becomes 10, right? It becomes 11. When it becomes 11, when this value increases to 11, this loop would terminate, right? And that's basically our normal understanding of loops that we covered in the previous two videos of chapter 5, right? But if this condition becomes true, which is I equals to 5, so we don't need to get to 11, right? That concept is gone because a value here is this condition is that the counter reaches 5, break out of that loop. Basically what it means is it doesn't matter if the condition is met or not, it's going to exit out of the loop and go back to the other conditions. It's going to stop printing the value of the I in the loop itself. So it's going to move out of the loop and move to the next code outside of the loop. So that's what a break statement does. So again, we understood that loop prints in this particular case, if we're going to be a little bit pedantic about it. So the loop prints 1 through 4, right? And when it hits 5, it doesn't print it because before this print statement here, before this print statement here executes that you see here, right? The if statement becomes true and we see the break keyword and we move outside of the loop immediately. We don't do anything within the loop, we move to outside the loop and move on to the next thing. With that understanding, you need to understand again another important factor here, and this is an important tip when using break statements. Use the break statement when you found what you're looking for and don't need to keep looping. So the break statement is always used on a condition that you're looking for in the loop. If you find something that you're trying to find through a loop, because in most cases with loops you're trying to find something, right, by running that loop in certain data or anything. When you find that something, you need to break out of that loop. Instead of continue wasting resources or time on that loop, you break out of it, you've got what you need, you move away to the next part of the code. So let's move on to the next thing, which is the continue statement, right? So unlike break, it doesn't stop the whole loop. Instead, it skips the current iteration and moves to the next one. What do I mean by that, right? So in break statement, when we hit 5, it didn't print 5. After printing 4, it moved with the 5th iteration, which is 5 of I counter. It saw the break statement, a condition meet, it went into the break statement and exited out of the loop. But when we, in this counter here, when I reaches 3 and this if condition becomes true, right, what happens is this continue statement comes in, right? What it does is it says, hey, I'm not going to ask you to exit out of the loop entirely, but the iteration of 3, let's skip that, right? Let's not print the system.out statement here. And let's ignore this statement and increase 3 to 4, right? And start the next iteration of the loop, right? That's what this continue statement does. Sounds very simple, but let me elaborate a little more here, right? So when I skips 3, we hit continue, Java skips the print statement, moves to right to the next number. What does this mean? It means that it's going to print 1, 2, oh god, this is the let me write it here. So it prints 1, 2, skips 3 because again continue statement does not allow it to go to the lower code in the loop and directly move on to the next loop. So it prints 4 and then it prints 5. Instead of 1, 2, 3, 4, 5, the continue statement only causes it to print 1, 2, 4, 5. That's it. So that is the core functionality of the continue statement. An important tip when you're using continue statements, you might want to skip. The important reason for why you need to use that is you might be looking to skip a particular case while keep looping. So if you in the break statement, if you found something you were looking for in the loop, you exit the loop because what's the use of remaining in that loop. But in the continue statement, you might want to skip a certain case within that data, and if you found that case, you don't want it to get added into the data, or you don't want it to become part of something, so you just skip the further statements within the loop and move on to the next iteration, ignoring that data point. So now that we understand both of these things, let's put it all together with a real world example. Say we're scanning user input for valid scores between 0 and 100. If the score is 999, it means stop input. That's where we'll use break. If the score is negative, it's invalid, so we'll just continue to the next one. So here's the code here, right? It has an array of scores from 85 to 92 to -3, 74, 999, and 66, as you can see within this block here, right? Then we use a simple a clean for loop here to go over every aspect of the scores array. This is what this means here, and you'll discover this more when we cover arrays in the next chapter, right? So let me just remove this. This is covering up, and we don't want it to cover up the code here. So now that you see that here, what you see further down the line here is that if score equals to 999, we need to break out of this loop. And if score is less than 0, we need to continue in this loop, right? So what would happen here? We'll print 85. Yep, that should be good. We'll print 92. That should be good. We won't print 3 because apparently it meets this condition here of the continue statement, which means we ignore 3 and move on to the next value, which is 74. So we print 74. Then we come to 999. And that is where the break statement executes. So that is, it would not print this. At the same time, the loop would exit, which means 66 won't be printed, because unlike the continue statement, which asks it to ignore 3 and move on to the next iteration of the loop, the break statement here is not going to ask it to skip the iteration. It's going to say, hey, we're done, let's move out of the loop and move to the next line of whatever code is on that line and execute that instead. So that's basically what that means is, along with 9999, any value outside of 9, further in the array, the 999 would not get printed. So that is what basically is happening with both of these values. And this is one example that helps you put in perspective exactly what's happening with break and continue statements. This pattern is super common in data processing, games, and user interactions. So this is very, very important to understand in particular. All right, let's do a quick recap on what we've learned. We've learned break exits the loop entirely, continue skips the current iteration of the loop. We need to understand that we use them in particular to write cleaner, more efficient loops and have better ways to control loop movements when a loop has already started. Just remember, use them wisely. Overusing break and continue statements can make your code harder to read if you're not careful. Keep your loops lean and meaningful. With that, thanks for tuning in to Smart Architectural Programming. If this video helped you level up your Java skills, give us a like, subscribe, and drop a comment with your favorite loop trick. With that, don't forget that this video is an important part of our companion series into Introduction to Java. And this companion series is a part of an Introduction to Java book. So keep flipping those pages of the book and coding along. And if you haven't grabbed a copy of that book, look for that copy on Amazon. And I'll add the link to our description below. With that, until next time, code smart and build smarter.